Ever stared at a jumble of flowchart statements in a GCSE computer science paper and just felt your brain totally freeze up? Yeah, we've all been there. But don't worry, today we're going to crack the code on one of these classic questions, and we're going to turn all that confusion into guaranteed full marks.
Okay, so this is the challenge we're tackling today. It's question 2 from the OCR J277/02 paper. It looks like a puzzle, right? You get an incomplete flowchart and a list of instructions all mixed up. Our mission? To put all those pieces together perfectly.
So here's our plan. First, we'll look at the exam challenge itself. Then, we'll figure out what the algorithm is actually trying to do. Next, and this is the best part, we'll look at the examiner's blueprint. After that, we'll build the flowchart step by step. And finally, we'll see how to lock in those full marks. Let's do it.
Right, first things first, let's break down what the exam actually gives us to work with. Think of these as our raw materials for building the solution.
You see, the question provides every single logical step we're going to need. We've got a start point, an input, a decision to make, 2 possible outputs, and an end point. So our job isn't to invent some new logic. It's just to structure it correctly using the proper language of flowcharts. All the pieces are right here.
Okay, before we even dream of drawing a single box or arrow, we have to ask the most important question. What is this thing actually trying to do? What's its purpose?
At its heart, an algorithm is just a recipe for solving a problem. And this particular recipe is designed to do one simple thing. Take a number, figure out if it's odd or even, and then tell us the result. The real magic happens with that num mod 2 equals 0 statement. All that's asking is, hey, when we divide this number by 2, is there a remainder of 0? If the answer is yes, well, the number is even. If not, it's got to be odd. Simple as that.
And now for my favorite part. We're going to look at the official mark scheme. This isn't cheating, not at all. This is just being smart. It's about understanding exactly what the examiners are trained to look for. This is our blueprint for a perfect score.
So, what is the big secret to getting all 4 marks on this question? Well, you might be surprised. It's actually simpler than you think, because the exam board lays it all out for us.
And what's really great is that they're not trying to hide it. The exam board literally gives us the recipe for success right in their own mark scheme. They're telling us word for word what they want to see. So, let's take a look.
You see, the mark scheme for this exact question breaks the whole thing down into 4 clear points. Get these 4 things right, and those marks are yours. We're going to use these points as our step-by-step construction guide.
All right, let's build this thing. We're going to put our flowchart together piece by piece, literally ticking off 1 mark at a time using that examiner's blueprint we just saw.
Okay, mark number 1. It's all about the shapes. The mark scheme is super clear. We need the correct shape for all 3 inputs and outputs, and it even tells us it has to be a parallelogram. Notice they're counting that 1 input and the 2 possible outputs. So first things first, let's place our start and end terminators. Those are always ovals. Now for the bit that gets us the mark. Input num, output odd, and output even all have to go inside parallelograms. And boom, just like that, our first mark is in the bag. See? Easy.
On to our second mark. This one is for the correct shape for decision, which, as you know, has to be a diamond. A good rule of thumb, anytime you see an if statement or any kind of question in an algorithm, your brain should immediately scream diamond. So we just take our if num mod 2 equals 0 statement and pop it right inside a diamond shape. Simple. We're now halfway there, with 2 marks secured. This is going well.
Mark number 3 is all about labeling the paths that come out of that diamond. Now, the mark scheme is incredibly specific here. It says true and false / yes and no must be labeled correctly. And it even tells us that the true path has to link to the even output. They're giving us the answer.
So let's do exactly that. The question inside the diamond is the remainder 0? Well, if the answer is true, the number is even, so that path leads straight to output even. And if it's false, the number must be odd, so that path leads to output odd. The labels are clear, the logic is sound, and our third mark is officially in the bank.
And now for the final mark. The examiner is looking to see that all lines joined up correctly and link to end. This is the bit that ties it all together, making sure the flowchart has a logical, unbroken path from the very start to the very end. No dead ends allowed.
And here we go. We connect everything up in arrow flows from start to our input. Then from the input to the decision, the two paths from the decision go to their correct outputs. And here's the critical bit. Both of those output paths then come back together and flow into the single end determinator. That is a complete logical flow, and that's our fourth and final mark.
We did it! So with all that done, let's take a look at the finished product and really nail down the key things you can take away and use for any flowchart question you ever face.
And there it is, the perfect 4-mark answer taken straight from the official mark scheme itself. You can see how it hits every single one of those marking points we just walked through. This right here is the gold standard.
Now, to help all of this stick, here's a little cheat sheet. Honestly, the biggest takeaway from all of this is to just know your symbols. Ovals for start and end, parallelograms for any time data is going in or out, and diamonds for any kind of decision or question. If you just get the shapes right, you are already well on your way to a fantastic score.
Okay, so we've completely mastered the odd or even problem, but let's push it a little. What if you needed to check if a number was positive, negative, or 0? That's 3 different options. How would you change this flowchart to handle that? Something to think about.